Okay, everyone, we're at the top of the hour. This is Chris Fregly. Thanks for joining us. I'm sure we'll have a few more people joining over the next couple minutes, but I want to get started. We are recording this. I've got a guest speaker today, Francesco Mosconi. He and I attended the TensorFlow Dev Summit last week. And Francesco, are you there?
Yes, I'm here. Can you guys hear me?
Yeah. Perfect. And Francesco is going to run us through some of the latest TensorFlow 2.0 features and also show us some eager, non-eager execution, which is one of the biggest changes within TensorFlow 2.0, the way that these graphs get executed and optimized. And let's see, any other housekeeping stuff? We'll be posting everything to youtube.pipeline.ai. You'll see everything. I'll go through, edit out the beginning of this, just getting rid of some of the stuff before the start of the hour, and then trimming it up on the end, pushing it out to youtube.pipeline.ai. So I think with that, Francesco, if you can give a quick overview and tell us what you're going to tell us.
Yep. Absolutely. Thanks, Chris. So I'm going to switch my screen to presenter mode. Can you guys see the slides?
Yeah, it looks good.
Oh, awesome. Okay. So some of you may know me through one of these programs, Data Weekends or Zero to Deep Learning or Catalyst. Basically, what we do is we run trainings for people that want to become proficient in machine learning and deep learning. And today I'm going to talk to you about what happened a couple of weeks ago with the TensorFlow Dev Summit that announced, amongst other things, TensorFlow 2.0. We are going to see what the most important changes are in TensorFlow 2.0 and how it differs from the 1. The most recent is 1.13. As well as how it differs from the open source version of Keras, which I guess most of you are familiar with. So let's get started from what happened last August. Last August 2018, on the TensorFlow community mailing list, there was an announcement about an upcoming TensorFlow 2.0. This announcement contained a few key points, which were then expanded at the Dev Summit. And here's a summary of the key points in the announcement. First of all, one of the feedbacks that the TensorFlow developers took from their experience with the first two versions of TensorFlow is that the community wanted to be more engaged in both the design process and and more involved with the clearer documentation. So what they did, they announced the 2.0 in August, and then they opened for a public design process, which we'll see what it means. So that people could contribute ideas and basically ask how define the changes collaboratively. So that's been a big thing and quite active. The biggest change, and we'll talk a lot about that, is the fact that eager execution became, with TensorFlow 2.0, becomes the default mode in TensorFlow. So that gets rid of the graph altogether. And the third big change, which we'll talk about today, is that a lot of the old APIs have been deprecated and restructured to reduce the amount of clutter and duplications. A lot of people have noticed that TensorFlow had offered several ways of doing the same thing, and so a bit of cleaning up of the API has been brought in TensorFlow 2.0. Amongst other things, they announced that what would be the plan for compatibility and continuity with TensorFlow 1, as well as the deprecation of TF contrib and more platforms and languages. So as I said, on March 6, 7, there was the Dev Summit, and TensorFlow 2 Alpha was announced and released. So this you can use right now. It's as simple as in pip install TensorFlow and put the 2.0 version. As you can see here, at the bottom of this slide, it's the 2.0 alpha 0. And so you can already get started. And let's take a look at the architecture of TensorFlow 2.0. Basically, there is a drastic simplification of the whole architecture of TensorFlow. There is a unified procedure to input data. This is in the TF data module. And this supersedes all previous methods like queues and runners and feed dictionaries and so on. It's fast, and it has an API that looks very much like a data set from the data frame from Pandas or Spark. So that's the one thing. And the model building API has been uniformed on Keras. So TF Keras becomes the default way of defining models. There is still an implementation of estimators, but the implementation is now made in terms of Keras layers. Also, and this had been introduced before, there is the availability of pre-trained models in TensorFlow Hub. So you can have models that have been trained on data by other people and use them directly. One big novelty in TensorFlow 2 is the distribution strategy. This was available in Contrib, and it's become a full first-class citizen in TensorFlow 2, which allows you to decide where you want to train your models, on which hardware, and how to distribute it if you're using, for example, multiple GPUs or multiple TPUs. This is really cool because it basically brings a bit of rationality and makes sense in what was a jungle of different ways of distributing your models, and not really easy API with the device scopes. However you train your model, you then can save it in a unified format called save model. And this is backward compatible, as in the models saved in TensorFlow 1 should still be deployable with TensorFlow serving or with TensorFlow Lite and the other deployment strategies. So some compatibility has been preserved with the previous version. And then, a save model can be, as I said, deployed in a variety of ways to JavaScript, to embedded, to mobile, or on a server in the cloud or on-premises. There have been introduced a number of language bindings. I think one of the most interesting developments, and it's not mentioned on this slide, was the announcement of TensorFlow Swift, which will be big for those of you developing for iOS. Yeah, so that's the architecture. Let's take a look at a couple of points in more detail. In particular, I want to look at these three: the public design process, the eager execution, and the deprecated APIs, and the reduction of duplication. Let's start from the public design process. Here are the three links to the resources that you can use to follow this public design process. So there is a Google Groups forum discussion, and then the TensorFlow GitHub repo has a community folder where you can find the request for comments. And you can monitor that repo to see which requests for comments are then approved and are decided to be implemented in the TensorFlow 2 spec. So that's the first place to go and take a look. The other place to go and take a look is obviously the documentation of TensorFlow Alpha, which is available on the TensorFlow website. And I'm going to go out of presenter mode for a second and show you this. So if you go to tensorflow.org alpha, you can see that there is a nice redesigned documentation that is much, much better than the previous documentation. It has lots of examples and lots of snippets of code, videos, and blog posts and articles explaining what's coming and what's new in TensorFlow 2.0. So it looks like the TensorFlow developer community has really taken a good look at how important it is for the community to have good documentations and good explanations and examples and tutorials, and they made an effort to make this available for the release of TensorFlow 2. That's great because it makes it easy to follow the changes. What's the timeline expected, and what does it mean for you? So they announced the alpha in March, and they expect to have a final release, full release by the summer, late spring or summer. If you are a TensorFlow developer that is familiar with the version 1 of TensorFlow, you should start updating your code as soon as the request for comments are accepted. And there is a conversion tool which is actually quite useful, and this is how you use it. It's a script that comes built in with when you install TensorFlow 2, and the way you use it is you pass a file and the name of the output file, and this script will try to upgrade all the functions that have a respective function in TensorFlow 2, and those that don't have a corresponding function in TensorFlow 2 will be simply changed to the compatibility module, which we'll see in a second. Second point I want to discuss, I want to overview today, is the eager execution. So eager execution is not new. It's been available since 2017, actually. And the idea is that it follows an approach that was introduced by PyTorch and Chainer, which is very much loved by people who do research. And there's a number of reasons why this approach is better. If you remember, in TensorFlow 1, basically the place where all the calculation happens is the graph. And this makes it harder to debug when you have a problem. It's very good for distributed computation, so very large scale models, but it's not so easy to debug and to understand what's going on. In contrast, the eager execution mode is a defined by run approach. So the calculation is defined and executed at the same time. So what this means, it means that there is no separation between a graph and a session. So you don't, the TensorFlow session object goes away in TensorFlow 2. Okay. The implications of this are that it's faster to debug, and also, more importantly, you can build dynamic models with a control flow that is basically Python control flow. You can also have custom gradients that were not possible to do in the graph, because the graph only supports the operations that have been defined and implemented by the API. The graph does not go away. It's still available through a compatibility module, which is accessible in tensorflow.compat.v1. And in particular, if you want to disable the eager execution, you have to call the disable eager execution function. So let's take a look at what this means in practice. I have a snippet of code here of quote-unquote old TensorFlow. You see I'm disabling the eager execution, and then I'm just instantiating in this case, it's a nested list, but it represents an array, and I do a matrix multiplication of itself. And what I obtain is a tensor whose shape is the correct shape, but the content is not there. This is what we all known and loved in TensorFlow 1. It's basically creating the graph. The graph is ready to perform a matrix multiplication, but the actual multiplication is not executed until you open a session. In contrast, in TensorFlow 2.0, which has eager execution by default, when you run the matrix multiplication, as you can see, you get the result very much as if it was an NumPy array. This is great because now I can see the result of my operations in real time and therefore debug my models much more easily. The second big change that comes with eager execution is control flow. Let's say I want to implement here a function that prints a different value. This is a typical FizzBuzz example based on a certain condition. And in TensorFlow 1, you cannot do this because the graph is static. So it would give you an error that the value that you're trying to convert to a tensor, the value max num, is actually does not exist. Okay, it's only the shape of the tensor, but it doesn't have a value. In contrast, in TensorFlow 2, you can do this very easily. So you can pass a number into your function and then convert that number to a tensor and range over that tensor and create the calculation dynamically. So the conclusion is that in TensorFlow, in eager mode, you can debug like you were, as if you were doing things with NumPy, but it still scales like TensorFlow to very large models. It's easier to build and test custom models because you can define functions. We've not seen that, but I invite you to look at the documentation. And it's a bit slower than the static graph mode. So I expect that they will improve the performance with the final release. The next thing I want to talk about is the removal of deprecated APIs and duplication. In TensorFlow 1.x, there are a number of different ways of doing things. There is the core API, which contains all of the operations on the graph. There is a TensorFlow layers API, which allows to define models layer by layer. There was introduced a TensorFlow Keras layers, which definitely was overlapped with the TF layers API. And there was an Estimator API that had a completely different implementation based on layers and allowed to use canned estimators, for example, like linear regression or multi-layer perceptron and so on. And there was also a contrib learn estimator API, which was basically already deprecated, but was an overlap with the estimator API. So a lot of different ways, a lot of disorder, a lot of organic growth, and this has been rationalized and stripped down. So what happens in TensorFlow 2? The core API is stripped down and simplified. Some ops go away, some functions go away, and a subset of the functionality is maintained. The old API is still available in the Compat v1 module. TensorFlow layers is completely deprecated. And this is because the primary API for definition of models through the use of layers is Keras. Okay, so if you've never used Keras before, I strongly encourage you to familiarize yourself with it, because that's going to be the API that stays. Okay. Contrib is deprecated and moved to a separate repository. So contrib learn estimator goes away. And the Estimator API stays, but the implementation of the estimator under the hood is actually changed to TF Keras, which is great because basically it makes the whole thing more compact and compatible. Okay. So let's take a look at Keras, which is the primary API. In particular, I want to answer a few questions. What is it? How does it work? And how does it differ from the Keras open source implementation? So Keras, if you've been living in a cave for the last few years, you may not know, but I assume you all know, it's the second most famous framework in deep learning after TensorFlow, and it's focused on ease of use and agility to learn. So it's been introduced as an open source framework a few years ago, and it was using TensorFlow as a backend. And what happened sometime last year is that TensorFlow decided to integrate Keras within the TensorFlow project, so much so that now the Keras API is the primary API. So how do we understand Keras in 2019? Well, Keras is basically an API specification to design deep learning models, okay? And the Keras.io version is an independent reference implementation of this API specification. And this still supports different backends. Okay, so you can use the default backend is TensorFlow, and the most recent release is compatible is using only TensorFlow 1. And the other backend that's compatible with Keras is CNTK. The TF Keras implementation is basically a TensorFlow implementation of the same API specification. Okay. What's happening right now with TensorFlow 2 is that Keras open source does not yet support TensorFlow 2. And I would guess that at some point the Keras open source project is going to slowly fade away. And that's because, this is really a guess. I have no information, like special information about this. I think that there is so much development power, so many developers behind TensorFlow, that the TF Keras API will advance faster than what the open source community can do. And so at some point, TF Keras is going to really branch away and be the only one that matters. I may be wrong on this, and there may be new developments in Keras open source. I'm curious to see what happens, basically. Let's take a look at how you define models in TF Keras, because there are a couple of differences with respect to the open source Keras. So there are three ways of defining models: the sequential API, the functional API, and the model API. The sequential API, I assume most of you are familiar with, so I'm going to focus on the changes. The first change is that you can define a model by passing a list of layers directly to the sequential class. In the instantiation of the sequential class, you can pass a list of layers instead of doing an empty sequential model and then adding the dense layers later on. Also, notice that here I'm taking the layers from within the TensorFlow.Keras layers module. So that's the first change. The other change is the optimizer. And this is a big and welcomed change. So in TensorFlow 1, you basically have two parallel implementations of optimizers, okay? Because Keras has its own implementation of optimizers in the backend, and TensorFlow had the tf.train .optimizers. these were completely independent. One of the big changes coming with TensorFlow 2 is that the optimizers have been unified and they're all calling the same functions underneath. So you can mix and match Keras and TensorFlow, and so you can define a model with Keras and then use the usual compile function that takes an optimizer and loss and a metric and then fit. But you can also proceed step by step like you would do in TensorFlow with the minimization of the optimizer. The functional API is a more evolved way of defining models in Keras. And in this API, you define models by specifying the inputs and outputs of each layer. And you connect the layers by using them as functions. So in particular, in this case, I define an input layer, which will receive the data. And then I define a second layer that is a dense layer, and I use it as a function on the inputs and return an intermediate output to a variable called x, and then repeat this operation for the next layer. Then I define a Keras model by specifying the inputs and the outputs. The advantage of using this API is that I'm not constrained any longer to sequential architectures. So I can do skip models and skip connections. So I can connect layers in an arbitrary graph without having to connect one layer to the next in like a stack. So more flexible. Even more flexible is the model subclassing approach, where I take the Keras model and define how it's initialized and what happens when I call the model. So this is even more flexible. It allows me to basically do whatever I want. So to summarize, the key differences between TensorFlow 2 and the open source Keras are the following. First of all, TensorFlow 2 supports eager execution, whereas the Keras open source is still based on TensorFlow 1. The way we pass the data to a Keras model is slightly different in the two versions. In TensorFlow Keras, we can access the TensorFlow data module and therefore have a very tight integration between the data feeders and the model. Whereas in Keras, the way we can pass data to a model is through Python data generators, which are a bit slower. Exporting of models is different because the TensorFlow Keras creates a model that can be saved with the saved model class, and therefore it's compatible with TensorFlow serving and all that out of the box. Whereas Keras is the open source version of Keras needs to go through the Estimator API if you want to export to a saved model, and it has its own way of saving to an array file that is basically framework independent, and you can reload it in any other framework. Also, the Keras, the TF Keras models are compatible with feature columns for inputs and compatible with estimators. There are a couple other things that have been announced, and I will not have the time to cover today, which are the compatibility and continuity with TensorFlow 1 and exported models, Contrib, and other platforms and languages. There is a nice blog post that I want to quickly take a look at. So I'll switch again my screen. In this what's coming in TensorFlow 2, you can take a look, and there is a lot of links, including explanations of deployment frameworks and saved models and distribution strategies and so on. So I encourage you to take a look at this blog post, which covers the key points also the ones I did not cover today. One more thing I want to mention, we have a bootcamp coming up next week that will cover some of these things. So if you're a beginner and want to jumpstart your career in machine learning and deep learning, you should definitely consider taking a look at our website. We run bootcamps. They're 5 days. They're hands-on, and you get to learn a lot of this stuff. So check out bootcamp0todeeplearning.com. And while I thank you very much for listening, I want to point you to a repository which is available at GitHub 0todeeplearning/tf2_Keras. And I'll put it in the chat so that everybody can see it. In this repository, you can find 2 notebooks that basically contain the snippets of code that I've covered today. There is an environment file with a minimum specification with Python, Jupyter, and TensorFlow 2. And the 2 notebooks, I have them open here, and you can find the code that I've shown today. So you have the example with eager execution and the FizzBuzz example, as well as a model with sequential API. And in the not eager version, you have the function and show that it breaks, as well as the 3 implementations of the models using the sequential, the functional, and the model subclassing approach. I hope this was interesting for everyone, and I would give it back to Chris and open it to questions if there are any.
Yeah, man, this is great stuff, Francesco. Thanks so much. I'm super excited about the boot camp next week. I'll be finally able to go for the full thing anyway.
Awesome.
Yeah, so stop by and can meet some of you folks. Looks like we have some questions there. Francesco, do you want to grab them? Anaconda version?
Sure. So Anaconda, I think it's still at TensorFlow 1.12. We can check together. Hold on a second. I'm pretty sure Anaconda will wait for the final release. They will not have an alpha module. Anaconda packages list. Okay, so let me share this. So if we take a look, for example, at the Linux Python 3.7 package list and search for TensorFlow, you see that it's still 1.12. So Anaconda is actually lagging behind even in the TensorFlow 1 version. We are currently at 1.13, which has quite a lot of changes with respect to 1.12, and that's because in 1.13 they're already preparing for the 2.0 upcoming release. So yeah, Anaconda is a bit behind. Let me have a look at the other questions. Some of the slides, I'll be sharing the slides. Yes, I'll be putting them on SlideShare, and Chris will send a link to everyone. Yep, I'll share the slides. Absolutely. I have not uploaded them yet, but I will do that after the call.
And for those of you that have the little zoom controls, like there's an arrow that's part of the controls. I think you can press up and it'll flip the control thing up to the top. I think you can also grab it and pull it to the side of the screen. Yeah, that's one slightly annoying thing about Zoom. They have gigantic control boxes. So I have a question, Francesco. What would you tell people that are kind of stuck, and like you didn't get a chance to talk about the 1.0 compatibility, but for anyone that is, looking to start a project today, would they start with 2.0? Should they hang out until Anaconda comes out, until the official GA? Should they just jump right into it?
Yeah, very good question. And I'll bundle your question with a question from Tamina that says, can you still do pip install at VM to have the desired version? So my advice would be to definitely start directly with TensorFlow 2 for a number of reasons. First, the documentation of TensorFlow 2, which is, I repeat, it's available here in the alpha subdomain, in the alpha here, tensorflow.org/alpha, is much better than the documentation for TensorFlow 1. So there is a ton of examples. Even like getting started is well done. There is an overview, and it covers a bunch of different cases. You have images, text, and even more advanced examples like GANs and variational autoencoders. So I would definitely get started from TensorFlow 2 if you're a beginner. I think the problem is more for people who are familiar with TensorFlow and have been developing TensorFlow code, where they need to basically relearn a way to think of models and how you write your code and how you organize your models. So that's my advice. Yes, you can still install it. You absolutely install it in a virtual env, and it will not clutter your default Python or other environments. So you just create a virtual environment and then just pip install TensorFlow. And let me show again, in the correct syntax is you pip install TensorFlow and you put the 2.0.0a0, or also the other way you can access the same package is to use TensorFlow 2.0.0-alpha0. Yes, so I would encourage you to start with TensorFlow 2 because the documentation is much better, and because when the final release comes later in spring, a lot of the things TensorFlow 1 will start to be not just deprecated, but be incompatible. And so the sooner you actually move to the new API, the better.
Okay, yeah, because one thing I always have issues with, even between 1.12 and 1.13, and is certain demos do get updated, certain ones don't.
Yeah, and that's
2.0. I know they're paying a lot more attention. Mm-hmm.
Yeah, that's a problem. A lot of the code that's out there in open source repos is going to be broken by TensorFlow 2, and so a lot of the examples will be incompatible, which is a great thing for authors like me, because it gives a chance to write more things and more blog posts. But yeah, it's going to be a bit of a problem. Let's take a look together at the migrate from TensorFlow 1 to TensorFlow 2 part of the documentation, because there are a couple of things that I want to point out. First of all, you have this disable v2 behavior that you can use, and you can import the v1 as TensorFlow, and you can basically still run all the examples without any changes if you use these two with the only exception of the contrib code, because contrib has been moved out of the repo. The second thing I want to point out is the conversion script, which I've been using, and it's actually quite cool. The way you call this upgrade script is you call the upgrade script passing a file and an output file, or even passing a whole directory tree and an output tree. And what the script does, it parses the code, and any function that still exists in the new version, it will basically rearrange the function in such a way that it's compatible with TensorFlow 2. So for example, here you have the argmax function, which is available both in old and new TensorFlow, but the syntax of the function is different. And so the script takes care of rearranging the arguments in a way that they are following the new syntax. If there is no compatible function that is found, what the script does is it basically just replaces the function with the compat v1 version of the function. And that's actually useful not only for compatibility, but it's also useful to learn what are the new things. Because if you look at the report after the script has run, you can learn and discover the new ways of doing things. One other thing that I want to mention about this upgrade script is that it works if the functions are coming from the TensorFlow library. So if you have imported the function, for example, from TensorFlow import a function, then it will not recognize it as a TensorFlow function. So my advice would be, if you have code that needs to be converted, to import TensorFlow and call all the functions as methods of the TensorFlow the TensorFlow package, so that the compatibility script will recognize them and try to upgrade them.
So one thing that was not very clear to me after the summit was performance issues between eager and non-eager mode. Like, do you have a good handle on that?
I have not done extensive testing, so I'm not really sure about that. What I know was that when eager was introduced, it was slower than graph execution, especially at scale. And that was one of the complaints that people, who are familiar with the graph, they were saying that since in eager mode, you're basically instantiating your calculation at the time of execution rather than defining them before and just flowing the data through it. If you have a very large model, that brings a performance penalty. I think that a lot of effort has been devoted to getting rid of this problem. So far I've not noticed performance issues, but as I said, I have not done extensive testing to have a final word on it.
Cool. And then, yeah, I know TensorFlow 1 was kind of bound by older versions of CUDA. And so I guess the sort of higher level question is, are there any major changes to the GPU support within 2.0? I think the minimum is CUDA 10, right?
Yeah, so it's CUDA 10 by default. It's the minimum. The biggest change is the distributed training. So the biggest change is this distribute package, which was available in Contrib already in TensorFlow 1. But now it's a first-class citizen in TensorFlow, which allows you to specify how you want to distribute your model over several GPUs. And it basically makes it much simpler. In TensorFlow 1, you use device scopes, and it's a bit of a nightmare to get it right and work with a lot of GPUs. What you do in TensorFlow 2, you just define what your distribution strategy is. And for now, in the alpha, only one strategy is implemented, which is the data parallel model training. And what you do is, once you have chosen your strategy, you just say with strategy scope, I define and compile my model, and then you can train the model. And what this does is it will distribute your model according to the strategy. So it abstracts you away from the low-level control on which GPU am I executing the code. You can still do that. Device scopes don't go away. So if you want to manually assign ops and manually assign models to different devices, you can do that. But there is a higher level API for distribution across multiple GPUs and also across multiple workers. If you look at multi-worker training, it's also part of the distribute module, and you can distribute over several workers. mirror multi-worker, mirror strategy, and that's in distribute experimental right now, but it's going to be moved to distribute once it's final release, and that allows you to run across a cluster, so that makes it easier. The biggest change, in my opinion, with respect to hardware is the tight integration with TPUs, which is this proprietary hardware that Google has, and TensorFlow 2.0 supports them really well, both for training as well as for inference. One of the nice gadgets that we all received at the Dev Summit was a little piece of hardware called an Edge TPU, which is basically like a USB key you plug into your computer, and it provides a TPU that is good for inference, and it's really, really fast. So that's, in my opinion, the biggest change with respect to like hardware underneath.
Okay, and there was a really good question on the chat here that actually I wanted to ask a broader question about TensorBoard. I know when I spoke with you this weekend,
yeah,
you and I were talking about TensorBoard and some of the the new profiling things.
Yeah, so TensorBoard is another really TensorBoard. Okay. So TensorBoard is another thing that got revamped and enhanced a lot. At the Dev Summit, they announced a lot of new features. So if you look at TensorFlow 2 Alpha with TensorBoard, you see that you still have the usual things like the scalar metrics, and you can track from models. You just add a callback, and you can post to TensorBoard. One very neat thing for those of you who use Jupyter notebooks is that they provide a TensorBoard Jupyter extension, which allows you to run TensorBoard from within the notebook. So in a cell, you just call %TensorBoard and specify the log there, and it will show TensorBoard in the notebook, which I find quite cool. But to me, the biggest changes in TensorBoard are the number of new things that have been added to TensorBoard. So not only the scalars and the images which were available, and the model graph, which is still available. The fact that the implementation does not have a separate graph and session does not mean that the model is not a graph. So you can still look at the model graph in eager execution, and you'll see what you're already familiar with, where you have the graph with all your nodes and how they're connected and how the data is passed through. So that doesn't go away. The interesting new tools are, for example, hyperparameter tuning, which allows you to compare different training runs in a much neater way. One of the things that you may have been doing in the past, I know because I've done it many times, is if you want to compare two different training runs, you would basically give them a different name when you save them to TensorBoard, so that you can recognize them. And if you start to have lots of runs, you have all these weird names like batch size 16 and learning rate and 3 layers, blah blah blah. What you do in TensorBoard 2, you have hparam tuning feature that allows you to compare runs and pass the hyperparameters as config variables. And so you can do parallel coordinates graphs of all the different runs and very quickly find what are the best combinations of hyperparameters and what are the hyperparameters that work. So that's cool. Another tool that was introduced in TensorBoard for TensorFlow 2 is this what if tool, which allows you to basically understand the model a little bit more in detail and look at how would the model classify a certain point by, you have an API with the features and you specify the inputs here. You have a UI, with the features, and you specify the inputs and the model, and it will show you where your model would classify that dot. So it kind of useful to inspect the robustness and the boundaries of your model. And as I said, the other thing is that you can access TensorBoard in the notebooks. There is a question in the chat. What about acceleration of SQL workloads with GPU, TPU in your experience? I'm not sure that SQL workloads are a focus in TensorFlow. Can you explain what you mean by SQL workloads? I mean, I understand what a SQL workload is, but what does that have to do with TensorFlow? I'm not sure.
Yeah, I mean, the classic question would be something about, how do we saturate these faster accelerators? This question seems to be something along the lines of
data feeding to the new models.
Right.
Okay. Or if that's what you mean, the primary way of inputting data to a TensorFlow 2 model is to use the data API. So I'm going to go back to my alpha documentation, and you see here that there is a loading data documentation, and that's where all is explained. And in the performance here, it explains how to build a pipeline. This is not new. This is available in TensorFlow 1 as well. You have these data sets where basically you point to a set of TF records, and then you can do operations on the data set. You can optimize for performance by pre-fetching the data and preloading the data to the GPU. And there is also this auto-tune function, which is still experimental, but that should basically find the best way to prefetch your data.
Oh, yeah, I don't think I'd ever seen the auto-tune thing before. Yeah, that's always been there?
No, I think this is a new thing.
It's a new one. Okay.
And it's still experimental.
Yeah.
So it will be finalized in the final release in spring, late spring.
This is funny. He was asked to write a white paper on this. Yeah, this is one of the most difficult topics right now, and saturating GPUs and TPUs.
Yeah, definitely one of the things that are tricky. It's like, now that we have so much compute power, is how do we feed enough data to saturate it quickly? Yeah, and the preferred way is this data API.
Okay, and for maybe like the last minute or so, can you just tell a little bit more about the bootcamp? And it's a pretty intensive thing, but like, how does it progress? And
yep, let me.
What are the prereqs for people that?
Let me open it. 1 second. Go to page here. Okay, so we run 5 days immersive trainings on basically Keras, TensorFlow, and scikit-learn. So we've worked with a bunch of different companies, and they all have very good things to say about us. So here is like kind of the content of the bootcamp, and let me see if I have a detailed schedule. 1 second. Oh, there we go. Okay, so this is the detailed schedule of the bootcamp. On the first day, we basically do all things machine learning with scikit-learn and pandas. So we cover regression, classification, and clustering, and go over standard machine learning techniques. And then from the second day, we dive right into deep learning, covering shallow models and deep models, fully connected models on the Tuesday afternoon. And then from the Wednesday, we go into more fancy and nicer applications like image classification and sequences forecasting, time series forecasting, and sentiment classification. So Wednesday is basically images day. So we do CNNs and tensors and all things related to images. Whereas Thursday is dedicated to recurrent neural nets, and we talk a lot about time series and text and text classification and so on. And then finally, Friday, we talk about TensorFlow, and so we review the different APIs and and talk about serving and deployment and so on. One of the nice things that we do in the bootcamp is every day we have some project work time, which becomes bigger from the Wednesday. So basically, there is 1 hour every day where you can work on a project of your own, and we are there to basically help you and help you debug, help you with ideas, help you scoping it. So if you have a project from work that you want to bring, you can definitely bring it there, and we can work on it together. In this particular event next week, Chris is also going to give a guest talk. So that's gonna take one of the hours on Thursday. And the other thing I want to mention is that for the members of the PipelineAI group, there is a nice discount that you can access. If you can access it in the meetup, or if you send us an email, we can definitely send you a discount code specific for you. So if you want to join, more than happy to accommodate. We still have some seats for next week, and then we'll do another version later this year. So that's, I think, all about the bootcamp.
Yeah, Francesco, somebody asked if there's a version in like New York City or any other cities.
Yeah, so great that you ask. We would love to come to New York City. We've explored a little bit the response that we would get in New York, and we had less replies than we get here in the Bay Area. So I'm more than happy to coordinate if you asking the question are from New York and would like to help us host one in New York. More than happy to start a conversation and see. Same goes for Seattle or Washington DC. More than happy to do that. Generally speaking, we need a starting group of about at least 10 people for us to make sense and organize it in a city. So yeah, more than happy to start a discussion and see if it makes sense to do it in any other city. How much is it? It depends how early you sign up. These are the current prices. The last promotion, which actually should have ended on Friday, but it's still active, is this price, and the door price is $3,500. If you buy super early, for example, in this case, over Christmas, we had a special promo of less than $2,000. And with the discount from Pipeline, you get an additional 10% off. So with that, you get basically a 5 days full-time course with me and TAs that are experts in the field. And you get to work on your project. You get a digital copy of my book and access to all the material and support in a Slack forum. So we have been repeatedly told that the value we offer is good for the price of the bootcamp. So that's the current offering. Yes.
Yeah, there's a lot of material. So.
Yeah, thanks,
up.
Michael. Yeah, more than happy to start a discussion about New York.
And then speaking of New York, it's the O'Reilly AI conference coming up, I think, in a couple weeks. And we're doing a meetup. I don't think Francesco's going to be there, but I'll be in New York, have some guest speakers set up from Comcast down in Philadelphia, and I think even a Washington, D.C. speaker as well from, I think, their Comcast group as well. So yeah, a lot of data science outside of SF. This is just where Francesco and I choose to live. So yeah, we're actually neighbors as well, too. We see each other.
Yeah, quite often.
Yeah, he gets skinnier and I get bigger, even though we go to the same exact gym. So yeah, not quite sure how that works, but yeah, man, thanks so much for spending the last hour. And yeah, thank you everyone for staying online.
More than welcome. Thank you everyone for the questions, and I'm happy to help if anyone has additional questions. I'll stop my sharing here, and yep.
And we'll post this in like the next couple hours or so.
Yeah, absolutely.
Sounds good. All right, everyone. Yeah, talk soon.
Bye.